So that's it for this particular problem. And Monday I'll spend one more lecture on fins where we will look at the second or third case where I have convective heat transfer conditions at the tip of the fin, and then we will solve a problem of that nature. Yes, sir?
Is it necessarily touching zero on that right edge, or not quite yet?
It's not yet. If I guess one should technically draw it to be equal to zero. Yeah. But you know, this is an approximate condition of an infinitely long fin. So it will eventually go to zero. So I'll do one more example on fins, and then Wednesday and Friday next week I'm going to talk about transient conduction, which will be on using the Biot analysis. You have a quick question?
Yeah, so in this case, the fin is cooling whatever it is down. Are fins ever used to heat something up?
You could do that. They are called as heating fins. So there is, I mean, it is the exact same principle, except that the ambient is hotter than the wall, and so there is heat transfer from the ambient onto the wall. So you can use them for cooling or for heating. But predominantly for us as mechanical engineers, they are cooling fins. Okay. So transient conduction, I'm going to spend like a lecture or a lecture and a half. I'm not going to spend too much time on that. You've come across that in system dynamics, I believe. Lumped capacitance analysis or lumped parameter analysis. I'll do justice to it, but I won't be spending too much time on it. And then I want to set out on this journey to radiation heat transfer. Radiation is going to take up around 15 lectures. 15 intense lectures. I just want to be very open with you about it. Okay? And then we will hit convection. Convection typically is taught last in heat transfer. The way I see it is because the convective heat transfer coefficient is an empirically obtained quantity. And to do an empirical analysis, you take in background from all different types of fields, from measurement systems, from fluid dynamics, from design criteria, from heat transfer, and then you come up with the convective heat transfer coefficient. But if you have that fellow, then all you are doing is applying Newton's law of cooling. So there is no secret sauce to the analysis there. If you know the empirical coefficient, you're done. So I will not be spending too much time on convective heat transfer analysis. There are probably 5 to 6 lectures on convection, but I want to get to heat exchangers, which is a very useful and a practical application of heat transfer. So we will cap off our last couple of lectures in this semester on heat exchangers. And all in all, understand that heat transfer is 3 things: conduction, convection, radiation. But it's just one big thing really, it is just the first one. Okay?